So this problem is essentially an Atwood machine with a human hanging on one end of the rope and a mass hanging on the other end of the rope. And we've done this problem in class already. So let's redo it. Situation is that there is a 200 kilogram mass on the right end of the rope, and then a 100 kilogram human that's just simply hanging on to the left end of the rope, and when this 200 kilogram mass is let go, this rightward mass will accelerate down, and the human 100 kilogram human will accelerate up, and we'd like to know what the acceleration is. So I have here a free body diagram for the human on the left here, and for the 200 kilogram mass that's on the right. So both of these are acted on by a equal and opposite tension force, both upward, using the massless string approximation. The human is acted on by downward by his weight, the attraction of the Earth, and the 200 kilogram mass is attracted downward by the Earth with a larger weight. And so the human accelerates up, and the 200 kilogram mass, which I call m sub s, accelerates down. The A's shown here have the same magnitude, but one points up and the other one points down. So we can now easily write a Newton number 1 for the human being, and that's simply going to be little m sub big M times A. That's little m sub big M is the mass of the human, 100 kgs, is equal to T minus little m sub big M times little g. Again, notice how I'm bookkeeping the signs here, the signs of the components. And then the Newton number 2 for the m sub s is m sub s times minus a, because a is pointing down, I have to do that, equals T minus m sub s times g. So this equation, which I'm going to call 2, can be rewritten as m sub s a is equal to m sub s times little g minus t. So if I add these two equations together, adding the right-hand side gives me the sum of the masses times the acceleration, and adding the right-hand sides eliminates the tension and gives me the difference of the two masses times little g, and therefore the acceleration is the difference of the two masses divided by the sum of the masses times little g, where in the numerator the larger mass is the first one and the smaller mass is the second one. So if we put the numbers in, that's 200 minus 100 over 200 plus 100, which is 100 over 300. In other words, it's 1/3 g, roughly 3.33, using easy numbers here. So that would be the acceleration upward of the human being, or downward for the 200 kilogram mass.